And welcome back, students, to our next lesson on exception handling basics. Let's today discuss some tips for exception classes. So our first tip is that of preserving getMessage. So for all your predefined exception classes, getMessage will return the string that is passed as an argument to the constructor, or it's going to return a default string if a no-arg is used with the constructor. Again, that's our no-argument constructors. So nothing's in the parameters. So, for example, if the exception thrown is as follows, throw a new exception. Wow, this is exceptional. Then, wow, this is exceptional is used as the value of the string instance variable of the object created. If the object is called E, as we very often seen, the method invocation e.getMessage returns, wow, this is exceptional. Now, obviously, what we want to do is kind of preserve this kind of behavior that we've seen in the exception classes that we can define. So, for example, let's just say we're defining an exception class called negative number exception. All right, obviously, we want to be sure that we can include a constructor with a string parameter that begins with a call to the super, as illustrated by the following. Public negative number exception, string message, super message. The call to super, of course, is a call to a constructor of the base class being exception. If the base class constructor handles the method correctly, then so will a class defined in this way. Additionally, we should also include a no-arg constructor in each exception class. The no-arg constructor should set a default value to be retrieved by getMessage. The constructor, of course, just like we saw in the last one, begins with a super call, as illustrated by the following constructor. Public negative number exception, super negative number exception. If getMessage works as we described for the base class, then this sort of no-argument constructor will work correctly for the new exception class being defined. And of course, you'll find a full definition of the negative number exception given in the class materials. All right, as we examine exception object characteristics, the two most important things to know about an exception object are its type, which is typically your exception class, and a message that it carries in an instance variable of type string. Now, this string can be covered with the accessor method getMessage, as we have seen with multiple times with like e.getMessage. This string allows your code to send a message along with an exception object so that the catch block can use the message. All right, let's just quickly discuss some stuff with programmer-defined exception classes. You may define your own exception classes, but every such class must be a derived class of an already existing exception class, either from one of the standard Java libraries or another programmer-defined one. So here's some quick guidelines. If you have no compelling reason to use any other class as the base class, use the class exception as the base class. All right, so if you're not like extending some kind of input mismatch, for example, let's say, which is coming from exception, you're going to just generally use the exception class to extend. Now, you should define two or more, depending on the situation, constructors, which we describe later on. Your exception class inherits the method getMessage, and normally do not need to add any other methods, but it is legal to do so. So you'll have like your no-arg, and then you'll have your string message. We should also start each constructor definition with a call to the constructor of the base class, such as using the following: super sample exception thrown. So you're always going to have a super call in there. You should also include the no-arg constructor, as I've already mentioned, in which case a call to the super should have a string argument that indicates what kind of exception it is. This string can then be recovered using the getMessage method. So, for example, input mismatch or divide by 0. You should also include a constructor that takes a single string comment. That's the one that has the string message parameter. In this case, the string should be an argument in a call to super. That way the string can be recovered with a call to getMessage. So here's a quick example. Public class sample exception, extend exception. Public sample exception, super sample exception thrown, public sample exception, string message, super message. You'll notice that this one right here is my no-arg, right? And here's your super call. And of course, this one, you notice, has the string message parameter, all right? And of course, here's our super message, all right? So those are the two examples there of something you have. So if I hit create any kind of exception, kind of on my own, here's kind of the template you can use. Just replace sample exception with whatever class you want, and you might have just to change your message. Other than that, there's not really much to it. It's actually pretty easy to define exception classes. Now, here's another tip. An exception class can carry a message of any type. It is possible to define your exception classes so they have constructors that take arguments of other types that are then stored in instance variables. In such cases, you would define accessory methods for the values stored in each of the instance variables. So, for example, if that is desired, you can have an exception class that carries an int as a message. So you can have just output 2, for example. In that case, you would need a new access method name set perhaps as getBadNumber. An example of one such exception class is BadNumberException, which I'll look at with you in a second. Now, the BadNumberException demo is a demonstration of how to use the accessor method getBadNumber. Now, note that this is just an example program, but it does illustrate the details of how an exception object can carry a numeric message. Okay, so let's pop over to Eclipse, and let's first look at BadNumberException right here. So you see if you have public class BadNumberException extends exception. We have a private int BadNumber. We have our constructor right here, BadNumberException int number, super BadNumberException, BadNumber equals number. We have our no arg BadNumberException with super BadNumberException. We have our public right here, BadNumberException, string message, super message. So this is very much what we've seen. And you'll see down here we also have our private int getBadNumber, return BadNumber. So we have different examples of how to do different type of calls here with our BadNumberException. If we look at the BadNumberException demo, this is a pretty easy one to look at here. We are getting input from the user, and we're pretty much asking him to enter either the number 42 or 24. So in here it does a check. If the input number does not equal 42, and if the input number does not equal 24, we're going to have it throw a new BadNumberException. Then, of course, if it throws and it catches right here, it's going to print line e.getBadNumber. That's not what I asked for. And either way, if it does go through, it's going to say thank you for entering, and then we'll say end of program. So let's just take a quick look at this. So let's just do a quick valid input. So let's just put 42. Thank you for entering 42, end of program. If I rerun it, but let's just say I put a different number, let's say 35, because that's not one of my numbers. And it says 35 is not what I asked for, and a program. Right, and that's going to kind of wrap it up for today, folks. So hopefully it gives you some ideas of how you could possibly go through and define your own exception classes. So until the next time.